sampling techniques was a part of it, right? And why random sampling was important. Yes, ma'am.
How do I get class in that?
How do you what?
Get class in that.
Say it one more time.
So you know the courses, I don't have.
Well, that's problematic. We need to get that fixed. We need to talk to the front office about that. Yes. Yeah, we'll figure that out. Okay. Please be aware what we're looking at right now is we need to be able to construct a histogram. We did that yesterday. I don't think the histograms were terribly difficult, were they?
No.
When we do a histogram, what do we just need to get first so that we can actually draw the correct bars?
Yeah.
Yes, we need data, but we needed the relative frequency for those groupings, right? So don't forget, you need that relative frequency to know how far those bars go up. Now, I do want to ask and remind you, what's the difference between a histogram and a bar chart? Okay, so which one doesn't touch? The histogram bars touch, the bar charts don't touch, but why?
Because bar charts is a category, right?
Bar charts go with categorical data, histograms go with numerical data. We want to keep that in mind, okay? Notice it's not just what is true, but why is it true? Why is this happening? That will help you in the future. We're going to talk about key features of a histogram, and we're going to talk about mean and standard deviation. All right? So we did this, we did that. We'll come back to the histogram later. Okay, so we're going to talk through these things. Now, this is not a histogram. What are these things called? Dot plots, right? We've got a whole bunch of dots. Please notice Brian and Jessica have decided to move and are considering 7 different cities. The dot plots below show the daily high temperatures in June, July, and August for each of these cities. Help them pick a city by answering the questions below. So remember, when you look at a graph, what are the 4 things you need to think about? Or if you look at data, what are the 4 things you need to consider when analyzing that data? Center. Unusual aspects.
CUSS.
There we go, right? Unusual aspects. Yeah. Keep listening, y'all, and forget what I'm actually trying to spell. Shape and spread. All right. So, when we look at cities A, B, and C, what's the most important difference for those cities? Okay, so they have the same shape. What else? They have different centers, which Hudson used what term for that? Average, right? Please notice, if you look at these shapes, they're exactly the same. They in fact have the same what other term? They have the exact same spread. They don't have any unusual aspects, but they do have the same spread. Actually, let me point this out really quickly. This is from third block. When they did Crazy in Love and they did their data, they had an unusual aspect. Notice how there was a gap right here. A gap like that would be an example of an unusual aspect. So a gap in the data. That's usually the biggest one that we talk about. I'm not going to test you on that. I just want you to be aware. I'm showing you all 4 of these. We're focusing on center, shape, and spread. But I'm showing you all 4 of these because when you analyze data, you CUSS it. All right. So most important difference. The center is different. Everything else is exactly the same. And so what are those measures of center that we could be using? Madison, can you get back there?
Yeah.
Okay, so you can use mean, median, and mode. Those are our measures of center. We're not going to go into calculating them right now, but we will talk about them. Right, those are the things that are different. All right, I want you to take 30 seconds, and I want you independently to consider C and D. What's the major difference there? Okay, quick show of hands if you want to share something that you see that's different there. I'm going to try to call on people I haven't talked to much today. Saman, you're one of the ones that raised your hand first, and I haven't heard much from you today. What's up?
D is flatter than C is.
Okay, D is flatter than C is. Anybody want to push back on that or add to that? Salita.
The temperature in the C are higher.
The temperature in C are higher. Anybody want to push back on that or add on to that? AJ?
The temperature in D goes higher, but the temperature in C has more.
Yeah, that's what I meant.
Okay, so we need to be careful with that language, right? Notice this goes actually to higher temperatures, right? But this has a higher frequency, or it has lower what? Variability. That's what we want to notice, right? So it has less spread, but it does actually have overall, or it doesn't have as high of temperatures. But I will point out, what about their centers? Are they?
It's the same.
I would say the center here might be around this point. Doesn't that look to be about the center here? And so that's what we want to notice. So what would we say here about C and D? C has less spread or variability. Okay? I should probably say Dan D. Is there anything else that we should say that's different about those two?
Their shape.
So what do you think is different about those shapes?
D's shape is a lot lower, while C's shape is a bit higher.
It's more like a constant rate. Spread out.
I was saying, does that have something to do with the shape, or does that have more to do with the spread? Ah, so that's more about spread. Okay, well, I'm going to talk a little bit in a second about what we mean when it comes to shape. Okay, so let's look at number 3, 30 seconds again. Look at it. What are the important differences between D and E? Alright, who has something to add in? Emma.
D has more spread than E does.
Okay, D might have more spread than E does. Madison?
There's a higher constant on E, and there's also an unusual aspect.
What's the unusual aspect?
The fact that there's a huge gap between like 72 and 60.
So those huge gaps right here?
Yeah,
Does anyone know the term for those huge gaps?
unusual aspect.
Yeah, it is an unusual aspect. There's an actual term for that specific one though.
Oh, we can start with.
It starts with an O.
We lost.
Okay, I'll come back to it in a second. Now, I will say this. If we were to look at the actual standard deviation, which we'll talk more about later, Emma is correct that there is less variability here, but I want you to look at it. Range is what? The same. So, in that regards, is the variability or spread different? Is that what you're going to say?
What's it
Sorry
called?
about that. Huh?
What's the other thing called?
Hold on a second. Let's let JC talk and then I'll get to your question.
So when she said that, it was like, the spread is the same, but there's two gaps, so it could be different, but they both spread out the same.
So when we talk about spread, right, there's 3 major types of variability that we address. It is the range, the IQR, which is called the interquartile range. I'm not going to test you on that. It's just I want you to be aware that there are these different variabilities, and the standard deviation. Or at least I'm not going to test you on it yet. I think it's in the book. I can't fully remember. We'll cover it when it comes up. So those are the different variabilities, right? And so what I will point out is, one thing I will say is this. Range, most of y'all are probably used to saying, hey, the range is from here to here. That's what you do in functions. With statistics, what the range is just the maximum value minus the minimum value. So let's say that this maximum value is 106. The minimum looks to be about 60. The range for both of those would be 106 minus 60, or 46 degrees Fahrenheit. You use a single number in statistics to describe the range. The range is just the max minus the min, okay? The range there, that measure of variability is the same. To answer Madison's question, we have what are called outliers. And those data points that are far away, so listen to me, data points that are far away from the majority of the data are called outliers. But I will also point this out. See how they have about the same center? Right? Right there. So when we talk about D and E, right, I would go ahead and make this note because this is something we would probably miss. Range is the same. So spread's not very different. But the range is the same because city E has what?
What?
What does city E have? Outliers. So that's what we want to be aware of there. City E has outliers. So now we have talked about center, we talked about unusual aspects, we talked about spread. Which one have we not talked about?
Shape.
Shape, right? Notice 4 says what is the most important difference between C, F, and G. Now, I'm going to tell you, you're probably not going to know the correct term for this, but how would you describe those 3 different graphs?
Staircases.
Okay, so one kind of looks like a staircase. Let's add some more detail into that.
G is more to the left, and F is more to the right, and C is in the middle.
So you said this G. So G is more to the left. Now, let's clarify language-wise, because this is important. And this is a small detail that trips students up. When you say it's more to the left, what are you referring to as more to the left?
Skewed, like left and right.
Okay.
Spread is more.
So what do we mean by skewed? Huh?
Spread is more to the left.
So when you say spread, okay, so I'm going to give you an important detail. The sides of these graphs like this are called tails. Okay?
Who would have known that?
Huh?
Who would have known that?
Don't they all?
When did I say that I expected you to know that?
Exactly. You say you
Don't
probably
they,
went out.
don't they all three like different? I don't know.
Okay, so that's actually a good question. Do they all have different middle points? Well, look again. Think about it. Are there about the same number of data points here as there are maybe here?
Yeah.
So they would actually probably all have the same median, because all a median does is separate the bottom 50% of data from the top 50% of data. So they would actually have about the same center.
What is one question?
That is a fantastic question. All right, so we want to notice, right, the tail is spread out to the right here. The tail is spread out to the left here. But right here, it has 2 tails, but what would we call that when the left side and the right side almost look the same? It's an S word.
Symmetric.
They're symmetrical,
Okay.
right? Okay? So what would we want to say? C, it's not perfectly symmetric, but we would say it's roughly symmetric. F, the tail is in which side? The right side. So when the tail is longer on the right side, we say that it is skewed right, or it has a right skewness.
Skew is a weird word.
I know.
You know me too, like cabal.
And so,
Oh, yeah.
if F with the tail to the right is skewed right, G with the tail to the left would be skewed left. Those are the shapes, or the starting point of shapes, right? Or you could say it's left skewness. Anybody need me to pause before I continue to the next slide,
Huh?
No, no.
which will be on the back side?
That's just weird.
What are your questions before we move forward? Open that up. Okay. I thought we were good when it came to statistical and non-statistical questions. I saw a whole lot of blanks today. Well, I can't give information away because I assume students are going to come back, but okay, so briefly illustrate the following distribution shapes. So one thing I'll say is this: when it comes to both histograms and dot plots, a lot of times we will just draw a smooth curve to represent what is there. So does that look roughly symmetrical?
Yeah.
And so I would just draw a little axis here, and I would draw a roughly symmetrical shape. It's not going to be perfect because I'm not an artist, and I assume most of us are not either. Within your small groups, okay, I want you to come up with sketches for your skewed right, skewed left. I want you to think about what it might mean to be unimodal, bimodal, and just see if you can come up with something that you might think is uniform. These are just sketches, just a couple of minutes. Talk with your groups to see if you can come up with something for each of those. We'll discuss it. One thing, make sure that you do have a little bit of tails on the symmetrical one, okay?
Would that be right?
What do you think?
Do you think that would be right for skewed left?
That's just it.
That's what I did.
That's what I'm thinking.
Remember, it's upside down for you.
No, because you didn't use art.
So what does it mean to be skewed left? The tail is to the... I'm just saying, I might erase it and make sure it's a clear curve with the tail to the left. Make sure it's at least a nice rough sketch. Guys, we should be on to the unimodal, bimodal, and uniform. Just something.
Are we supposed to guess what it means?
I mean, look at the notes that are given there. Talk with your group, see if they agree.
They're still stuck on the
I mean, it looks like most of them have symmetrical skewed right. One thing I'll say, Madison, is make sure you have tails.
Oh, wait, what do you mean by that? It's like,
Like, you don't have symmetrical skewed right or skewed left. You might want to talk to your teacher a little bit more about that. So, Madison, Madison, look back at the other side. Oh, that's the last one. So, but what I was going to say, a little swoopy, but I want to point this out. Do you see it coming back up at all for these skewed left and skewed right? So then why are you swooping back up with your tails? Tails flat down. Okay. I might extend my tail a little more. Okay, that's a single beat, right? Colin, why don't you figure the bimodal sketch up on the board? There's a thing up there. You can rate C, F, and G.
Can I do unimodal?
Sure, go for it.
I want to draw you from one of
So, I will say this, you're very close to what you're thinking about, but I will say uniform does not actually have a curve, but notice you've got to start, I will say you have to start at 0. So how can you get up to a line, draw a line to go uniform, and then get back down to 0? So it would look like what shape? A square, or what's a more broad term that squares fit into? Yes, but there's another one. Okay. Draw it up. Max, can I get you to draw your skewed right up on the board? I didn't ask. But sit with your group and show them.
To the right, and they just keep correcting.
I asked most of those people to get the response. Okay. Thank you. Thank you. Thank you. Okay, so I'm going to clarify a couple of things. A lot of these responses are good. I just want to push back on a couple of small details. Thank you. So, symmetry, right? Symmetrical. One of the things I want to point out, okay, hold on. I'm not saying that all these are correct. I'm pushing back on some of them so that we can learn from mistakes and learn that things that students did well, different things like that. One of the things I do want to point out is this. Always draw an axis underneath your curve. Okay? Draw an axis underneath your curve because at the ends, what is always understood to be there?
Nothing.
Nothing, or zero, right? So you need that zero there as a marker to compare against. Draw an axis there underneath, okay? So, I want us to look at this skewed right to start. Does anyone want to push back on that or add on to that, or are we good with it? It needs to be closed at the end, like on the left-hand side? That's a good question. What do y'all think? Does it need to come back down to the x-axis?
I think it does.
No, it doesn't. No, because what if it doesn't decrease?
It's still skewed right, even if it's not closed.
It is skewed right, but I want you to think about this. If I don't close it off, then isn't it just going to go infinitely this way?
Yeah.
Is it really possible to have infinitely data or infinite data?
No.
Eventually, it needs to come back to the zero. Okay. So be aware of that. With this curve, make sure that yes, we want a tail to the right, but we also need to start at zero. And start, come up, and then put the tail. Whoops, I did way too much symmetry there. So, there we go. Notice, there's still two tails, it's just the right one is longer. That's what we mean by skewed right.
Skewed to the left.
Skewed to the left means that the left tail is longer. Okay? And it takes practice drawing these. Alright, unimodal, bimodal, uniform. Let's look at the unimodal and bimodal first. Okay? Yeah.
Not the same song.
Excuse me. Yo, seriously? Focus. Okay? That's just an alarm to make sure I don't go over and I have time to wrap up. So, unimodal, bimodal, single peaked, double peaked. Does that look right? For single and double. Is there anything though that we should push back on with the way that it's currently there? Okay, so we need an axis. I would still say there's one more detail.
Maybe the
The ends points up.
Hold on a second. I thought I heard Malvoyer talking and then I heard a whole bunch of other people talking over her. I know I didn't hear that in my class. What were you saying, Malvoyer?
I was saying that maybe like the bimodal like wouldn't be so like low, because like sometimes like you'll have like those dips sometimes, but it wouldn't be so low.
That's true, but remember, like if you look at that bimodal over there, there's a whole gap in the data, right? It can get all the way back down. Okay, so it's a good thought. I like the thought. Yes, ma'am,
The
Salita.
tail's pointed upwards.
Oh, yeah. Do you see any of my tails pointing back up like that? No, tails are going to go towards the axis. They're going to be nice and smooth, right? We don't go back up. Don't do that. All right. And then uniform, no peaks. Straight up, straight across, straight back down.
I do a straight line.
Okay? Well, here's the thing though. We always need to start near the x-axis, right? So to get up to there, we have to have a vertical line. Now, I will say I would extend the x-axis so that the uniform distribution has an x-axis to follow against. Okay?
Wait, so is it true? Are you serious?
Is what true?
That it can be a square.
It was like, whoa.
So, I mean, think about it though. And I will say this. I wouldn't... Hey, hold on. We still have time. Don't pat myself up. It's not just a box or just a square, it could be a rectangle in general, right? There just can't be a peak, so it's uniform, it's the same all the way across, right?
So some many words, no curve.
Yes, the only reason why I won't say no curve is this. Well, this could be a distribution. There's no curves there, but is that uniform? Does that make sense?
When it said no peaks, it's not straight.
Right. No peaks just means it's a horizontal line across the whole time, right? No peaks, because again, that has a peak. It's not a curve, but it has a peak still. Okay? So, how do you describe the distribution of a quantitative? By the way, we use the word numerical. What do we use to describe a distribution of a numerical variable? What do we use? We talked about it multiple times so far.
What was the question?
Well, how do you describe the distribution of a numerical variable? Center is part of it.
CUSS.
CUSS.
I see it for y'all.
That's what I'm talking about. If I'm asking you to describe a distribution of a numerical variable, I'm asking you to look at the CUSS. Alright? What are the two most important things to remember when you are asked to compare distributions? What do you need to look at for all the distributions? You need to compare their
Chart. Mean, I usually ask it.
the mean, which is a measure of
Center.
center. You need to compare their unusual aspects. You need to compare their shape, and you need to compare their spread. You need to compare all aspects of CUSS. And here's the last detail that we haven't hit on much, but in context.
Hold your breath.
Right? So earlier we were talking about the temperatures of those cities, right? So the center of the temperatures might be about blank, right? The center temperature for those cities might be about blank. The spread of their temperatures is about the same. Always use context. I'm going to ask that you complete this one comparison over the weekend.
Gotcha.
Complete that one comparison so that we can get back to the textbook on Monday. Please make sure you take your name cards, put up your calculators, and please note, complete that comparison of distributions on the supplemental sheet. I might take a picture to remind myself. Look at Schoology or something.
She's all over town.
I am tripping.
I'll get mayor that
Oh yeah, does anybody else need to come back during enrichment to finish the understanding test?
Raise it up and beyond.
I just need to do the first.
Oh, my leg. Oh, my leg, oh, God. It's already.
That's was that you saying,
Email Mr. Robertson.
Robertson?
I'm gonna switch. You bullying me.
Can you come back to who do you have?
No, come on. Come on.
Melbourne, who do you have?
Mr. Prana.
Prana, Miss or Mr.?
Missing.
Yep.
Hey, Mr. Kenny.